Hello everyone, welcome back to my channel. In this video lecture, we will cover a new chapter of chemistry, that is general principle and process of isolation of elements. So these are the metals. Aluminium, it is exported from ore, bauxite, and its composition is this. Iron is extracted from hematite, magnetite, siderite. Many ores are there. So these are the metals and these are their ores, and this is their composition. Metallurgy is the process of extracting pure metal from their ore, and minerals are the mixture of metal compounds, soil, sand, limestone, and rock. Gangue are the impurities present in ore like mud, silica, etc. And ores are the minerals from which metals can be extracted economically at low cost and with minimum cost. Flux is the substance added in furnace to remove gangue. Slag is the fusible mass formed when flux combined with gangue. Smelting is the process of extracting metal from their oxide ores by reducing the roasted oxide. And the major steps involved in the extraction and isolation of metals from their ores are: first, crushing and grinding ore; second, concentration of the ore; third, roasting and calcination of the ore; fourth, reduction of the metal oxide; fifth, refining of the pure metal. Then concentration of ore. Hydraulic washing, it is the washing away of lighter gangue particles from the heavier ore. It is based on gravity difference between the ore and gangue particles. Then magnetic separation takes place. This separation is carried out if either the ore or the gangue is attracted by a magnetic field. Then froth flotation method. This method is used for removing gangue from sulfide ores. Depressants are used for separating two sulfide ores. For example, for separating ZnS and PbS, NaCN is used as the depressant. Then leaching. If the ore is soluble in some suitable solvent, then this process is used. For example, ore is the ore of aluminium, bauxite, silver, and gold. Then leaching of alumina, these are the reaction. Then isolation of crude metal from concentrated ore. It involves two-step conversion into oxide, then reduction of oxide into metal. Then thermodynamic principle of metallurgy. For any process, the change in Gibbs energy at a temperature is given by delta G is equals to delta H minus T delta S, and delta G naught is equals to minus RT log K. Reaction will proceed when the value of delta G is negative. Extraction of iron from its oxide. Limestone is decomposed to CaO, which removes silicate impurity as slag. Then pig iron is the iron obtained from a blast furnace, which contains about 4% carbon and impurities like S, P, Si, Mn in small amounts. Cast iron contains about 3% carbon, is obtained by melting pig iron with scrap iron and coke using hot air blast. Then extraction of copper from cuprous oxide. Copper matte contains CuTs and Fes, and it is put in the silica lined converter to convert the remaining Cu2s and Cu2O into metallic copper. Then extraction of aluminium. Purified Al2O3 is mixed with Na3, AlF6 or CaF2 to lower the melting point and bring the conductivity. This is the overall reaction. Then the electrolytic process is known as Hall-Héroult process. Then copper from low-grade ores and scarps. Copper is extracted by hydrometallurgy from low-grade ores. The solution containing Cu2 plus is treated with scrap iron or H2. Then extraction of gold and silver. Metal is leached with NaCN or KCl. Then Ag is oxide to Ag plus and Au is oxide to Au plus. Then refining, purification that is, and first is the distillation. The impure forms of low boiling metals like zinc and mercury are evaporated to obtain pure metals as distillate. Liquefaction, low melting metals are separated from higher melting liquids by allowing them to flow on a sloping surface. Electrolytic refining, impure metal is taken as anode and the stripe of pure metal is taken as cathode. Copper and zinc are refined by this process. Anode mud obtained during electrolytic refining of copper contains antimony, selenium, tellurium, silver, gold and platinum. Then zone refining. First, the principle, the impurities are more soluble in the molten state than in the solid state of the metal. Then germanium, silicon, boron, gallium, indium are refined by this process. Then vapor phase refining, the requirements that the metal should form a volatile compound with the available reagent. So the volatile compound should be easily decomposed so that it can be recovered easily. Then Van Arkel method for refining zirconium or titanium. They are used to remove oxygen and nitrogen present as in impurities. Then chromatographic methods. Principle is the different components of a mixture are differently absorbed or on an adsorbent. Then chromatography involves a mobile phase and stationary phase. There are several chromatography techniques like paper chromatography, column chromatography and gas chromatography. So this much for today's video. Hope you liked it and understood it. Thank you for watching my video.